Light a match. For 1 second, a tiny sun burns in your fingers. Then it's gone, and the warmth fades into the room, and you can't feel it anymore. But here is the strange part. That heat did not vanish. It cannot. Energy is never destroyed. So where did it go? And where is all the other heat? Every fire, every engine, every warm breath we have ever made. There is a rule the universe never breaks. You cannot create energy, and you cannot destroy it. You can only move it around and change its shape. The heat of your match was once sunlight locked inside a tree. It changed form again and again, but the total never changed, not by a single drop. So all of it is still here. Every joule we have ever burned is still somewhere in the world. The question is just, where? To find it, follow one piece of energy on its journey. Start with a lump of coal. Burn it and it boils water. The steam shoves a piston. The piston turns a wheel. The wheel moves a train across a whole continent. Useful, powerful. But at every step, a little leaks away as warmth. The hot engine, the squealing brakes, the rumble in the rails. And when the train finally stops, all that motion turns to heat in the brakes and drifts off into the air. This is the second law of thermodynamics, and it is relentless. Energy doesn't just move, it runs downhill. Look at the light bulb above you. You think it makes light. Mostly, it makes heat. And even the light it makes doesn't last. It strikes a wall, a book, your skin, and is absorbed. It becomes a little warmth, too. Your phone, your car, your body, all of it is the same story. Energy goes in as something useful and comes out as low, useless heat. Everything we do ends in the same place. Warmth, spreading out into the dark. Now, widen the view. Add it all up. Every power plant, every car, every device, every body on Earth. Right now, human civilization runs on roughly 19 trillion watts of power. 19 terawatts, burning all the time. And almost all of it, in the end, becomes heat. We are, quietly, one of the warmest things this planet has ever built. So surely that is what's heating the world. All our furnaces and engines cooking the sky. But here is where it gets strange. That heat is almost nothing. Compare it to the sun. Every moment, the sun pours about 10,000 times more energy onto the Earth than our whole civilization makes. Our own heat warms the planet by a tiny amount, far less than a tenth of the warming we actually see. The heat we make is not the problem. The problem isn't how much heat we add, it's how much heat can leave. Picture the Earth as a single object hanging in space. Sunlight pours in and the planet warms. But a warm planet glows, not with visible light, but with infrared, the same kind of heat you feel from a radiator in a dark room. Earth is always radiating that heat outward, back into space. Energy in from the sun, energy out into the cold. For most of history, the two were balanced, and the temperature held steady. Then we changed the air. We dug up ancient carbon, burned it, and filled the sky with carbon dioxide. These gases let incoming sunlight pass straight through, but to the outgoing heat, they are not invisible at all. They catch some of that escaping warmth and send it back down, like a blanket over the planet. The sun still shines the same, but now less heat can leave, so the Earth warms until it glows hot enough to force the heat back out again. So back to the question, where does all our heat actually go? In the end, almost all of it leaves. It climbs through the air, escapes the atmosphere, and radiates into space as infrared light. And space is vast and almost perfectly cold, about minus 270 degrees, a whisper above absolute zero, the coldest anything can ever be. The warmth of your coffee, the heat of a candle your grandmother lit, some of it is already gone, falling forever through the dark between the stars. But not all of it leaves right away. While the blanket thickens, the trapped heat has to go somewhere. Most of it goes into the sea. The oceans have swallowed more than 90% of the heat we've trapped. They are deep and slow and patient. You cannot feel it, but the water is warming, top to bottom, a vast hidden reservoir of our heat, and it will leak back out, slowly, for centuries. Step back and a pattern appears. Energy is never lost, but every time we use it, something is. Not the amount, the quality. Concentrated energy that can do work keeps spreading into thin warmth that can do nothing. A hot cup in a cold room always cools. It never heats back up on its own. The arrow only points one way. Physicists call it entropy, and it always increases. And this isn't just our story. It's the story of everything. Every star is a furnace, spilling its heat into the cold. Slowly, everywhere, the universe is evening out the difference between hot and cold. Run that forward far enough, and you reach a strange ending. A universe where everything is the same lukewarm temperature, where no heat can flow, because there is nowhere colder left for it to go. Physicists call it the heat death of the universe, the final stillness, when nothing can ever happen again. But that is trillions of years away. Tonight, the universe is still full of differences, still full of warmth falling toward the cold. And you are one of those warm things. Right now, your body is glowing gently into the room. Your heat is leaving you, joining all the rest. Every fire we have ever lit is doing the same, rising, spreading, slipping out past the sky. All the heat we've ever made is not gone. It's just leaving. A long, quiet exhale from a small, warm world into a very large, very cold night.